Okay, this is section 3.4. This is on logical arguments, and this is that culmination of everything we've done in chapter 3. So an argument consists of two parts. We've got the given statements, called the premises, and the conclusion that is based on these premises. So let's just dive right on in, okay? Example 1, let's use a truth table to determine if an argument is valid or invalid. Here's my argument. If it is cold, then my car will not start. My car starts. Therefore, it is not cold. Okay, this is the argument. Okay, so these two things up here are called the premises. These two statements. This little 3 triangle dots here is a symbol for the word therefore. It means that there's a conclusion coming. And then this statement after those 3 dots is my conclusion. There is a mathematical way of determining if an argument is going to be a logical argument. Like, does this make sense? If it is cold, then my car will not start. My car starts, therefore it's not cold. Is that a rational, logical conclusion to make from these premises? Well, let's see. Symbolically, let's go ahead and write this statement out in symbols. Let's call P the statement, it is cold, and Q, my car starts. This statement up here, if it is cold, then my car will not start. That's an if-then, a conditional statement. Okay. If it is cold, so that means just plain old P is first, then my car will not start. So I called Q, my car starts. So that means I have to put a not on here for that top statement up there. My car starts. Okay, that's just Q. And then I've got my conclusion. Therefore, it is not cold. All right, P is the statement, it is cold. So that means I have to put a not symbol on P. So here is this argument written symbolically. Now, here's how we're going to determine with a truth table if an argument is valid. It is valid if the conjunction of the premises implies the conclusion is a tautology. And that's a mouthful. So we're going to need a truth table for the conjunction of these two statements. So there's the top premise, and then there's the second premise. So the conjunction of these two premises implies the conclusion if this statement right here is a tautology, if it's all true. So I'm going to have to build a truth table for this guy right here. Okay. This is the final boss here that we need. All right, I want to zoom in just a little bit. So this guy right here, there's my final boss that I need. That's that conjunction of the premises implies the conclusion. But I got to do a lot of building to get up there, right? I've got this stuff in the parentheses, but I got to do a not Q first. Then I can do the conditional. Then I can do the conjunction of those two. But then I got to do a not P before I can do that, that conditional statement. Okay, so let's get cracking on it. Not Q is just the opposite of the Q column. So that would be false, true, false, true. This is a conditional statement. So this is that promise. It is going from P to not Q, and it is directional. So you know we need that direction. Going back to my summary sheet, the conditional statement is a promise. It is only false when you go from true to false. All right, I'm going from left to right, from P to not Q. True to false. Okay, that's the scenario where it's false. True to true is okay. False to false is okay. False to true is okay. This one looks like a lot, but it's not. It is just one operation. It's just the conjunction of this column that I just built and Q. So it's just the and, or the conjunction of those two columns. The and, or the conjunction, is only true when both are true. All right, this is only true when both of these are true. Both of these are not true. Both of these are not true. Ooh, both are true. Both of these are not true. This is only true when both are true. Okay, next up is not P. So that's the opposite of P. That's instead of true, true, false, false. That is false, false, true, true. I'm not going to highlight that one. And then last up, that column looks like a hot mess. But remember, because of how we've been structuring the way we build these, this is one single operation. It is just the conditional statement, and it's going from all of this to this. And it's a conditional, so it's directional. The conditional statement is only false when there is a fire, but you don't call 911. All right. Only false when I go from true to false. Okay, false to false is okay. False to false is okay. True to true is okay. False to true is okay, right? There was no fire, but you called 911 for some other reason. Okay, now look at this last column. If it is a tautology, remember that's just the fancy pants words for, the term for all true, then the argument is valid. If there's one or more falses in this column, the entire argument is invalid. So this is all true. So the argument is valid. These are going to be a lot of work, but the way Alex structures this is actually kind of nice. It really walks you through the process. All right, so let's look at how Alex is going to have this laid out. So it says, use a truth table to determine if the following argument is valid or invalid. So the stuff in black is what you're going to be given. Okay, and we're already given it's already given to us symbolically, which is so helpful because then we don't have to write it symbolically to start with. Remember, these things up here above this line are the premises, and the thing after this, therefore, is the conclusion. Part 1. So Alex is going to break this up into a four-part question, just to help walk you through it. Part 1 is going to say, write the argument as an implication. That is telling you to use this form of premise, this top line, conjunction, premise, the next line, implies conclusion. These two are fixed. What you put in here for these two premises and what you put in for the conclusion are dependent on what is given to you in the original problem. Okay, so this premise, the top one, is that P to Q. So I've got P implies Q. There's my top premise. Conjunction, my bottom premise, P and Q. Now, to group these together as all one thing that's going to imply that conclusion, I'm going to put another set of parentheses. You can also use brackets if you wanted to. That implies my conclusion, which here is just P. So that is my argument as an implication. Implication is this arrow. So this is the form you're going to use every time. So this is just kind of a formula that you can use every time. So here's the answer that you're going to put in Alex. Those parentheses are needed. So don't look at those as being optional. You do need those parentheses. Okay, next up it says draw a truth table. Now, this truth table, it may only give you these two and then the last column. All right, so you will likely have to fill in the middle stuff. This is my last column. So here's what I have to build toward. All right, let's start in the parentheses. I need the P to Q, got it. I need a P and a Q, got it. Then I need to do the conjunction of those two together, got it. Last up, I'm going to need to do the conditional from this mess to P. I've already got P, so I don't have to do anything there. Because I end up writing so big, I often cannot fit everything onto one page for the truth table. So I kind of have an abbreviation that I've started using, and you are welcome to join me on this journey. What I usually do is all of this mess over here on the left, once I get my column built for all of this mess, I will call it star. And then my last column, rather than rewrite all of this stuff, I will just abbreviate it and just put star implies P. That way, this star is just my abbreviation for all this mess that's on the left side. So you don't have to do it that way, but I just find that I write so big that I am constantly struggling to fit it in to where you can still see what I'm doing and read it. And it's just exhausting. So I just finally was like, you know what? I just need a better way. So this is not something that Alex does. So this is just my own little shortcut that you're welcome to borrow. Okay. The way that Alex has this split up, it's got part 2 and part 3. It splits the truth table in half. It's going to give you the first 2 rows as part 2, and then it's going to give you the last 2 rows as part 3. I do not know why it does that, but it just does. So just know that when you're doing these on separate paper, when you're showing your work, that when you go to put this answer in Alex, that part 2 is going to be just the first 2 rows, and part 3 is going to be the last 2 rows. So just know that going in. All right, let's start filling in the truth table. P to Q and P and Q. Those are great. We've got those. We can just copy those straight from this sheet. We love that. Okay, so conditional P to Q is just true, false, true, true. All right, true, false, true, true. P and Q also on this sheet. True, false, false, false. True, false, false, false. This is starting off really nice, isn't it? So copied from the summary sheet. All right, this one, it looks a little menacing, but we know by now that it's always just one operation. The only thing new in all of this is that conjunction right there, that and. And what am I, anding together? This P to Q and this P and Q. So I'm doing the conjunction of those 2 things. So there's my operation. There's who I'm doing it to. I come back over here. My and is only true when both are true. All right. Only true when both are true. Both are true. Okay. This is only true when both of these are true. Both of these are not true. So both of those are not true. Both of those are not true. So only when both of them are true is when that's true. All right. And then last up, this is a conditional. There's my one operation. And where is it going from and to? It is going from star, that's this column, to column P. Remember, it's directional, so I need to make sure and draw that just so I know what direction I'm headed. This is my promise. It is only false when it goes from true to false. When there is a fire, but you did not call 911. Okay, I'm going backwards. I'm going from star to P. So I'm going from here to here. True to true. That one's okay. False to true. That's okay. False to false, that one's okay. False to false, that's okay. Remember, the only one that's false is when you go true to false. And remember, we're going from this direction to here. Now, lastly is part 4, and it just says, is the argument valid or invalid? We're going to look right here, okay? Boom, right there. That column of all truths, that last column being all true at tautology, is whispering little sweet nothings to you and telling you that the argument is valid because that last column is all true. So these are kind of exhausting. You can see that there's a lot of work that has to go into them. But I hope that, I'm kind of giving you a good layout, some formulas and stuff. So this will just be a drop-down menu in ALEKS where you just pick one or the other. Okay. So, example 3. We're going to use a truth table to determine if the argument's valid or invalid. Again, here's the original problem. Just like last time. Part 1, over here, we're going to write the argument as an implication. So remember, I had a formula of the first premise. So P, biconditional Q, conjunction with the second premise. All of that implies the conclusion. You can tell the premises from the conclusion because the premises are always above the line, the conclusion's below the line, and after that therefore symbol. So when you put this in ALEKS, it's going to have all of these symbols in there for you, so you don't have to find those on the keyboard. Okay, let's draw a truth table. Starting in the parentheses, I've got that biconditional P and Q there. I've already got Q. I need a not P eventually. There's the conjunction. The word left me there for a second, of these two. So, and then I got my not P. Then I've got the implication from this mess to not P. So again, I told you that a lot of times this stuff over here on the left-hand side gets really messy. So I will call that star, and then my last column will be star implies conclusion. That way it tells me which one to go back to, but without me having to write all of that and cram all that stuff into that column. Okay, so the first one, this biconditional, is just plain old biconditional between P and Q. We can just copy it down from the formula sheet. True, false, false, true. So that'll just be true, false, false, true. So that just came directly from the summary sheet. Next up, this is just one operation. It's just the conjunction of the biconditional and Q. All right, so it's just the conjunction, the and. It is only true when both are true. This is only true when both of these are true. All right, both are true. No, they're not both true. Those are not both true. Those are not both true. The not P is the opposite of P. So that'll be false, false, true, true. And then lastly, we have my implication that's going from star, this mess, to not P. And it is directional. The conditional is the promise. It is only false when you go from true to false. I'm going from left to right. True to false, that's when it's false. False to false is okay. False to true is okay. False to true is okay. Is this argument valid or invalid? This one is invalid. because there's at least one F in this last column. Even just one false messes up the entire argument. We need that last column to be all true, a tautology, in order for the entire argument to be valid. So this one's invalid because there is at least one F in that last column. Okay. Some of our arguments are common enough that they have names. That means we run into these kinds of arguments enough that they have a name and we know ahead of time if they're valid or if they're invalid. We can skip building a truth table. Oh my gosh, this is so great. We love these, okay? These are the valid argument forms. That means if you have an argument and it starts off in this form, boom, valid, no truth table needed. This is called the law of detachment. And this is the argument of if P then Q. P happens, therefore Q happens. So this is a valid argument form. And specifically, it's called the law of detachment. We have the law of contraposition. It says that if P then Q, not Q, so Q doesn't happen, therefore P does not happen. We have the syllogism. This one is also sometimes called the law of transitivity because it says if P then Q and then if Q then R. Well, this says, hey, how about we just skip going through Q, right? We skip the middleman and just go straight from P to R. So that's what this one says. Then we have the law of disjunctive syllogism. Now, all four of these are valid argument forms. Okay? This one, this law of disjunctive syllogism, has this disjunction, as you'll probably guess, and it comes in two forms. It says if you have a P or Q statement and P isn't true, then Q must be true. This one says, oh, if Q isn't true, then P must be true. Because if it's an or, one or the other, or both, have to be true. Okay, the next few are invalid argument forms. Now you're going to notice that the valid argument forms all went from being called laws to the invalid ones are called fallacies, meaning they are not true, they're invalid. So we have the fallacy of the converse. This one says if P then Q, and then Q happens, therefore P happens. No, not necessarily. If there's a fire, then I will call 911. Just because you called 911 doesn't mean it was a fire. We have the fallacy of the inverse, is this form. We have the fallacy of the inclusive or. And this is that, P or Q, P happens, therefore Q didn't. Well, no, Q could happen as well because it's an inclusive or. It means that the or is a one or the other or both. So with these, the nice thing about them is that it's going to tell you, right, in the homework, write the argument symbols, then decide whether it's valid using the common forms of valid arguments and fallacies. That means you're going to determine its validity, is it valid or invalid, from using those forms, not from a truth table. Okay, so let's write this in symbol. So this is an example from the homework, and it's like homeworks number 6 through 10. So that's what these are going to look like. Okay, if it is sunny, I will wear SPF 50 sunblock. All right, so let's say that P is the statement, it is sunny. And those two kind of ran together on me. End up looking like one word. Oops, got that backwards. So we got P is going to be, it is sunny. So Q is going to be, I will wear sunblock. All right, so let's write this out in symbols. If it is sunny, I will wear SPF 50 sunblock. This is an if-then. This is one of those scenarios where Alex did not give us the then. You just had to know that it was implied. So it is an if-then. So I'm going to put a little happy thought cloud up here, letting you know that then is just kind of lingering. So this top premise is an if-then, and it's from P to Q. Sunny, wearing sunblock. If-then. If, then, that's why I picked that symbol. My second premise is it is not sunny. Well, P is the it is sunny, so this must be not P. All right, so that was not, so that's why I threw the not symbol on there. And then my conclusion is I will not wear the SPF 50 sunblock. So that's going to be not Q. All right, so again, I've got that not right there. That's why that not showed up on there. Okay, so now all we have to do is go look at our previous forms and match it up. All right, so we've got an implication and then a not P and a not Q. So let's go back. So, we got an implication, P to Q. We got a not P and then a conclusion of not Q. Boom, it matches this one. It's the fallacy of the inverse. Because this is a fallacy, it is an invalid argument. So you're going to have to, and Alex, you're going to have to pick, is it valid or is it invalid? And then you're going to have to pick why. If it's valid, you're going to pick one of those laws. If it's invalid, you're going to have to pick one of those fallacies. So you're going to need both of these in your answer. You're going to have to pick if it's valid or invalid, and then you're going to have to pick if it's one of the laws for the valid or one of its fallacies for the invalid. Okay, so that finishes us up for section 3.4.